So my video got interrupted halfway through, so if it's alright, I'm just going to talk through what I just did. If it's not, I can resend it, but I swear to God, it's all my own work. So here's my situation. I have a mass of 80 kilograms being pushed with a 200 Newton force at an angle of 40 degrees. It started at rest, so I have an initial velocity of 0 meters per second. My change in position is 12 meters, and my time is 3 seconds. So my first step, and I'm trying to find the acceleration. So my first step is to use an acceleration equation, and so I used the one that fit all the variables I had. So I wrote down the equation, and I eliminated this term because it would equal 0 because time multiplied by my 0 velocity is 0. So I plugged in everything I knew, which 12 meters is equal to 1/2 times acceleration times 3 seconds squared, which is my time squared. And then I got 2.7 meters per second squared as my acceleration. So then my next step was to make a system schema, which I did, and then a force diagram, which I also did, and I had a diagonal, so I split it. My FA became FX and FY. My FN is bigger than my FG because it has to compensate for the extra forces, specifically the FY pushing down with the FG. Then I wrote down my force equations, which are Fy plus Fn plus Fg is equal to Ma, which is actually 0 in this case, and F of F plus F of X is equal to mass times acceleration. And so I need trig now to plug in all of these. Oh, these are all of the vertical forces, and these are all the horizontal forces. And then so then I built a triangle. I wrote down a triangle with my degrees and my force amount that I had given to me, as well as my Fx and Fy. I then wrote down the equations for them for the trig, and now I'm solving for them. Okay, so now I'm back to where I was. 200 sine 40 is equal to 128.6 newtons. So with sig figs, that's going to be 127, or it goes up, numbers go up. 129 newtons. You know what, actually, yeah, whatever. 200 cosine. And then I got 153.2 newtons. So 153 newtons. Okay. So now that is my F. Let's see. Sine is that's Fy. I probably should put that. That's Fx. Okay. So now I'm going to solve for my gravity force so I can get the rest of that equation. So my gravity force equation is F of G, so force of gravity, is equal to mass times the force of gravity. Wow, that's right, it's hard to see. Okay, so that's my variable is equal to mass, which is 80 kilograms times 9.81, and that, hold on just 1 second while I calculate. Sorry about that, hold on. 80, 21, 784. So force of gravity is equal to 784.8 newtons because it's a force. So I've now solved for all of the variables in this equation. And so I'm going to plug those in to the first one. Yes, okay. So force of y I found was equal to 153 newtons plus normal force. Oh, which I actually haven't solved for yet, which is what I'm doing next. Right, so I'm going to just leave a blank spot there for a minute. And that I found, the force of gravity I found equals 784.8 newtons. And then, yeah, is equal to 0. Whew, okay. Yeah, so then, actually, just kidding. I'm going to solve for this right now because I know it equals 0. So, wait. Yes. So 153 plus 784.8 is equal to 937.8 newtons is equal, oh, actually, I'm going to call this X for now. I guess I should really call it Fn because that's what it is. Plus Fn plus f of n is equal to 0. So that means f of n is actually negative 937.8 newtons. Yay! Okay. So then I'm going to solve for my second equation, this one. So the force of friction, oh, I forgot friction up here. Okay, at least I noticed, so yay. Friction is going the opposite direction, perpendicular, wait, that's normal force. It's opposite to the applied force. So that's actually force of friction. Sorry, I forgot to include it. It's less because the box is actually moving. Yeah, please don't take that objective away. Okay, so then my next equation is force of friction is equal to mu, or the coefficient of friction, times normal force. And so, haven't actually solved for the force of friction yet. Because, just kidding, I remembered this, I'm sorry. Okay, so that's not yet. This is what's next. F of f plus f of x is equal to ma, which is the all-important unbalanced force equation. It's the reason it's unbalanced. Sorry, it's hard to see. So, I'm going to plug in what I know, which I don't actually know force of friction yet, so that's my unknown. My f of x I do know because I solved for it. Oh my god, I used the wrong one. Gosh dang it. This is not actually... Wow, okay, I'm sorry. This is like the worst video ever. Okay, this is not 153. So, that just adjusts my calculations a little bit. Okay, this is actually 128 because that's the one I solved for over there. Or 129. 129 newtons. I wish you could pause videos and start over. And then, yeah, so then I'm going to subtract again, or add them together and then subtract it. So 129 plus 784, 913.8 newtons, and then 913.8 newtons. Okay, not so bad. Fixed it. No problem. Okay. Fx, which this is the 153. So f of f plus 153 is equal to mass, which is 80. I know that. Kilograms. This should be newtons. Times acceleration, which I found earlier, 2.7 meters per second squared. Yay! Okay, so now I solve for force of friction. Just give me a moment while I do that. So I got 216 plus, okay, and then I subtract 153, 63. Force of friction is equal to 63 newtons. It's kind of a funny number. I hope I did it right. Okay. So, now that I have my force of friction, I can now solve for the coefficient of friction using this equation, which I tried to write earlier, but realized I did wrong. Okay, so now my force of friction is 63, hopefully that's right, is equal to mu of f of n, which I solve for is, yeah, that's going to be a really small number, negative 913.8 newtons. Ah, come back. Okay, and then I solve for that. So, oops, wow, that's a very small number. I probably did this wrong. Wait, no, confidence. Okay. Wow. Mu is equal to negative 0.07. Can mu be negative? Let's hope so. And that doesn't have any units because the newtons cancel. So now I have solved for acceleration, which I actually did really early on. But hey, I've solved for a lot of things now, so I'm just going to show you all of it. I apologize for wobbliness and other stuff because I'm actually holding this while I solve this. So I hope this is good. If it's not, that's unfortunate. Thank you very much for letting me send it to you.